So I want to take the derivative of an integral, so I'm going to use the fundamental theorem of calculus, but notice that this doesn't match the two of the three items that I need. The lower bound isn't a constant, and my variables don't match. So first thing I'm going to do is concentrate on putting the lower bound as the constant. So I'm going to do a number line, and again I'm going to assume that x is less than x squared. So I'm going to pick a number between x and x squared. Doesn't really matter which number you pick. I'm going to use 0. And again, I'm assuming that x is smaller than x squared and that 0 is between x and x squared. So I'm going to rewrite this as two different integrals. So I'm going to go integral from x to 0 of t minus 1. And then I'm going to go integral from 0 to x squared of t minus 1 dx. So on the first integral, my lower bound is not a constant, but my upper bound is. So I'm going to use the properties of integrals. That means that I can switch the upper and lower bound as long as I make it into a negative. And then for my second integrals, the variables don't match, but we're going to come back to that and say that we can multiply by the chain rule, so we can multiply by 2x. So the derivative of the integral are going to cancel each other. I'm going to substitute my x. Lower bound is a constant, so I'm going to have negative x minus 1. For my second integrals, my variables don't match, but I just need to remember that I need to multiply my answer by 2x, incorporating the chain rule. So I'm going to substitute for x, multiply by 2x, combine my like terms, and I get 2x cubed minus 3x plus 1.